Hi there. Welcome back to our 3D Heals 2020 speaker interview series. All of our speakers have amazing stories to tell and are great resources for anyone who wants to innovate in healthcare 3D printing and bioprinting. And the intention behind these interviews is to decrease the distance between our speakers and the audience before 3D Heals 2020. And you can think of them as icebreakers for you by us. Today, we're fortunate to have Dr. Shafkat Anwar from UCSF to join us for a short interview. Dr. Anwar is trained pediatric cardiologist and also in cardiac MRI, but he's also someone I consider a pioneer in the field of 3D printing for congenital heart disease and also 3D visualization and 3D technologies in general. Thank you, Dr. Anwar, for joining us today.
Thank you.
The reason that we're doing these interviews is to decrease the distance between the audience and our speakers, whom I consider have amazing stories to tell. And so here, this short session is just to get to know you a little bit more, to hear about your journey in this healthcare 3D printing journey. So why don't you tell us a little bit about, how did you got acquainted with 3D technologies at first?
Thank you, Jen, for the kind introduction. So I will say I'm an accidental guest into these technologies. So as you mentioned, I'm a pediatric cardiologist, and my background is in cardiac MRI and cardiac imaging. And essentially about 8 years ago, I would have considered myself very traditional on that track. My research was with imaging research, and my clinical work was making diagnoses of kids with congenital heart disease. And then things changed about 8 years ago when our surgeons, at this time I was at the Washington University in St. Louis, our head of cardiothoracic surgery asked me to print him out a heart model for a child with congenital heart disease so he could plan the procedure in advance using a 3D printed model. I had no experience with 3D printing at the time. In my training, in fellowship, I sat next to a 3D printer, and that's literally it. I didn't have actual experience on 3D printing, but flash forward a couple of years, I was heading the cardiac MRI program, and when the surgeon made this request, I felt that it was important to fulfill the request. And that's because I saw the potential in the technology. At that point, there were some early publications, and Shijun Yu up in Toronto at Toronto Sick Kids is doing some amazing work in congenital heart disease. So there was some precedent. So at least I felt brave enough that there is proof of concept. So I sort of jumped into it. But I had no actual education and frankly, very little knowledge. And the way we succeeded was by collaborating. I was very fortunate. I started working with some very smart engineers, biomedical engineers at medical modeling and now 3D systems. And we had a very simple collaboration. They wanted to learn congenital heart disease and cardiac segmentation and printing, and I needed 3D printing for my patients. So we collaborated, and over a year, we taught each other. We fine-tuned the models to a point where I felt that they were accurate enough to use for clinical cases. And then we started applying them clinically, getting feedback from our surgeons, and kept iterating to make the models better. Flash forward a few years, our hospital and the university got behind us and sponsored us to create a center for 3D printing, which we did at WashU. And that was because there were many pockets of 3D printing, not just cardiac, but craniofacial, dentistry, et cetera. And we wanted to centralize this activity. And I was fortunate enough to be one of the founders of the 3D Center at WashU. And lo and behold, we had just finished that project, and I was invited to come out to UCSF and to build a center here with kind of a broader mission, a broader vision, which is to bring in what we're now calling 3D plus technologies. So not just 3D printing, but the electronic components of advanced visualizations, things like augmented, virtual, mixed reality, and provide it to the entire community of patients we take care of at UCSF and other referring institutions. So a couple of years ago, I kind of made the jump to come out
Yeah.
to the West Coast. And
Yeah.
now we're leading the Center for Advanced 3D Technologies here. And I couldn't be happier. This is a great place to do this type of work because of the community we have here.
Yeah, I was really happy to see you move here. I remember the first time that we met a couple of years back when you moved here. A couple of points here is, first of all, when you said that you did the case for the CT surgeon in WashU, do you remember what year that was?
Yeah, that was about 7 years ago now.
So 2013 or something like that. You know, I don't think anyone had any 3D printing experience or education in our field. You know, in healthcare, I don't think many people had. So I think you're probably one of the few people who actually, at first, you're the very earliest people who did those kind of prints.
Thank you. I should specify, 2013 was when we first started, but my first clinical print was about 2014, because I try to be as meticulous as possible so that we're as accurate as possible.
So funny story is that the first time I encountered 3D printing was probably around 2014. And the first model that I encountered was actually congenital heart models. They were in a box with sections. I think those are printed by 3D Systems. And it was an amazing experience as a radiologist. So my background as a radiologist, you never see these patient models actually in a physical form. And I didn't realize how small they are because they're kids' hearts, right? Like a walnut size. And that's when I realized how challenging these surgeries are. Because, you know, on a screen, we can magnify stuff and they don't look too small, right? But in physical form, it's really incredibly risky surgery.
Right.
And you mentioned that there are many iterations before you can perfect these models. Do you have some milestones that you were looking for? And like, do you have any stories to tell these earlier cases where you're just trying to get it right?
Yeah, absolutely. So the first thing is you're spot on, right? As an imager, you're used to nice big screens or even a huge display when you're talking about this at conference, which doesn't really show the technical challenge of these surgeries, right? I mean, the reason I got into this, and I was, to be quite frank, hesitant to get into 3D printing because I knew at least the time and effort that it takes to do this right. You know, the type of expertise that you would need to develop to get a model where you're confident enough to plan these surgeries off of. But on the flip side, I recognize how difficult our surgeons' jobs are. Just like you said, the pediatric heart is about the size of a walnut. The arteries and veins are about the size of spaghetti noodles. And the structures around them, the structures that can be damaged, like the nerves or the lymphatics, they're the width of a few strands of hair. And the lymphatics, as you know, they're about the consistency of wet tissue paper. And if any of these structures are damaged, you're looking at more time in the intensive care unit, a worse outcome, or if you don't get the surgery right the first time, you have to come back and reoperate. And that's worse morbidity and even, you know, mortality for our patients who are so vulnerable. And that's why I felt that this is important to do. But probably the smartest thing I did was knowing how dumb I was, right? I mean, I'm a cardiologist and I'm a doctor. I needed to partner with true professionals who know medical image segmentation, who know computer-aided design, who know printer technology. And so the way we've been able to be successful, and not just us, any center that's doing this on a center-wide basis, and we're not talking about one-offs where one person's trying to do this in one division with one printer. For this to work as a center, we have to be able to collaborate among one another. But what has been amazing about places like Stanford, UCSF, other academic centers is, you know, these expertise, they live in-house, and if they don't, then they are in the community. And that's actually why I'm such a big fan of 3D Heals, because, you know, a community like this brings together professionals, and there are the networks that are needed to bring these technologies right to the bedside, because we can't do this by ourselves. As far as milestones go, I mean, my models are kind of, I time by the age of my child, who's now about 7 years old. So I started printing a little bit before she was born. The first print we did was single color and rigid. And I thought, I can't use this. It's a blood pool model, and it shows the outside of the heart very nicely, but it doesn't show the connections. So we kept iterating. We made them flexible. We made them hollow. We made them cuttable, multicolor. Along the way, there were multiple fails, right? I mean, that's the nice part where you can iterate. You try different things because, as you know, there's many types of printer technologies and so many choices out there now. And we've now arrived at something that's cuttable, flexible, multicolor, which I think is a nice combination for not just the surgeons, but our trainees and our families, because we use them for education also. But who knows, in a few months, our models may not look the same as what they do right now, you know, because, you know, we keep tinkering.
Yeah. You know, I talked to people like Shannon Walters at Stanford also. And in a way, I think you guys are super lucky in a really good position to test out a lot of these newest technologies. And then you mentioned 3D plus technologies are actually the umbrella that you're working under, in addition to 3D printing, which you're obviously an expert in. And I agree with that. I think 3D printing is not the only tool we have as doctors. We definitely have a variety of tools. So what are your visions or plans? Because there's so many, you know, technologies, kind of overwhelming in a way, right? You have VR, AR, and you have advanced visualization tools offered by a variety of imaging companies. Like, do you have some kind of plan or strategy for the UCSF 3D Technology Center?
Yes, well, the way we're approaching it is that these are different tools in a toolkit. And we're defining our work by our mission. And our mission is simple. We want to use these technologies to improve patient outcomes, to teach our trainees, and to engage our families with family education and counseling. And then you pick and choose. So for 3D printing, it's relatively straightforward, if you will. I believe you do need a medical grade 3D printer that prints in high resolution, and the color is nice to have. So, you know, that kind of narrows down your printer choices. For the 3D plus or the advanced visualization systems, as you said, there's different components. You can have augmented, virtual, or mixed reality technologies. And again, I think we define it at UCSF by the use case. So for large lectures, a platform like EchoPixel, where you have a display system that you use glasses, it's not completely immersive, and everybody wears glasses and you look at a screen through a 3D projector, and that's nice for large lectures. Or completely immersive virtual reality, which may be nice for cases where you don't have to 3D print, you don't have to print a whole case. And so you can use VR or MR for that. And then what I'm very excited about is augmented reality technologies with devices that we're carrying around in our pockets every day. You've seen these technologies with the Merge Cube, for example, and an iPhone. I can project a hologram, if you will, or an AR image of a heart. And for a family, you know, that's very accessible. I can show the family right on my iPhone by rotating the cube, which will look like a heart, what the anatomy is. So you're absolutely right. There's lots of technologies out there, but we try to be judicious about picking and choosing. And that's really just defined by the use case.
Yeah, you know, AR, VR used to be, you know, to me as a more of a side gig, you know, that field I'm focusing on. But I have to say, the pandemic that we're experiencing right now kind of forced me to look more into AR, VR, just on a personal level. You know, I started to play with some of the games. I started to experiment with these neural tools. It's actually becoming a lot more relevant and forced us to look deeper in these technologies, which also bringing up another topic, and I think we briefly chatted about it previously, is how is this COVID-19 situation changing your current role and work and life?
I mean, obviously, it's been a big disruptive force for the whole world, right? I mean, everyone's affected. We're all in this together. And in medicine in particular, as you know, a lot of the clinical activity ramped up heavily in the acute COVID response, but a lot of the clinical activity kind of paused in the elective field, in the elective realm. So for us, for the center, if I can speak about the cardiac experience, you know, UCSF, we held all our elective cases to allow our staff to respond to the COVID crisis. But because at our center, a lot of what we do is planning for elective cases, the clinical activity sort of paused for about a month or so. We also had to pivot very quickly to go from working in an office to, like the rest of us, working from home. And thankfully, with these technologies, our experience has been that you can work on 3D modeling remotely almost as easily as you can being on site, and then coming in very selectively for printing. But because we had a pause, and because of our kind of combined personalities where we can't sit still, right? We can't sit still even if we wanted to. We started thinking about ways to address the COVID response in our own way. One of my partners, Alexis Dang, he started printing face shields because there was, as you know, everywhere, there's a lack of personal protective equipment. UCSF reached out to our center, and we got together about 18 printers and brought them all to our library, and pretty quickly gathered a group of volunteers, and they're now printing about 300 face shields a day in-house to meet that need. I started looking at hands-free technologies, simple stuff for door openers. As you know, COVID can be spread by the contact route. So we started adapting door handles, the design that was inspired by Materialize, and we adapted it for our doors, reinforced them, made them stronger, and now they're in pilot testing to be deployed so that when people start coming back into the hospital in larger numbers, we restrict the number of people that are exposed, hopefully, through the contact route. And this is where 3D technologies is so powerful. We can prototype and iterate so quickly, especially if you have in-house technologies. And for these, we didn't even use our high-end printer. We used our simple FDM printers. They're low cost, they're fast. And so these are two solutions that we came up with pretty quickly. On the other end of things, we're looking at printing nasal swabs, and obviously these are being done already at many centers. What we're hoping to do is print them faster. So this is a prototype design that can probably speed up our turnaround time by about 7 or 8-fold. And this is in preclinical testing right now. So the beauty of these technologies in the medical space is that we're always kind of evolving and finding new reasons to use these technologies. So thankfully, we've found some ways to help with the COVID crisis.
Yeah, I want to add to that is that long-term investment in technologies, a 3D printing center or a 3D center like at UCSF now is paying off in a way because it adds agility to your whole hospital and your whole practice. The talents that's in this group really is, really, it's like X-Men power, super people are coming out with their abilities that in a time of crisis is super helpful at this. Yeah.
That's kind of you to say. I mean, I'm just trying to keep up. There's so many brilliant people in the Bay Area. And as you know, there's a coalition that is dedicated towards finding technologies that address the COVID crisis, and not just the Bay Area. I mean, you've done this work internationally. I get texts from my friends in India texting me things that they're printing out, and again, pretty inexpensive FDM printers, and they're using it the next day. Again, face shields and things that protect them while they're intubating patients. So the technology liberates people to find solutions.
Absolutely. Well, I very much look forward to your presentation in a couple of weeks. Actually, we're very close. And meanwhile, please take care and stay safe.
Thank you.
Thank you, Dr. Anwar.
Appreciate your time.